Yeah, thank you for reminding. All right. So the question, the sheet for this week is this one, right? So the first question is that you have a random sample from an exponential distribution, and we want to find the MLEs, maximum likelihood estimates, or estimators of VAR and ES, right? Can you take a few minutes and see if you can do it? Guys, I'm disappointed with the number of people turning up today. It's only 13 today. Don't know why. Yeah, maybe I mean, by the way, quiz 7 uh, is due next week, but next week is, as you know, Christmas time. But so if you're going somewhere for Christmas, you may want to submit it before the end of this week. But if you are still around, you can submit it next week before the deadline, which is the 22nd of December, 12 o'clock noon. But it's up to you when you want to submit it, all right? Okay, so I mean, as usual, I will mark everything and return it to you on the same day. Okay, and all right, guys, let me know if you have any questions, guys. All right. By the way, do you have any questions with the test? All of you got your test back on the same day as your test. I know it took me a lot of time for marking, but it was okay. If you have any questions on your mark or anything, just please let me know. Right. Okay. All right. Now let me show you, if you haven't done it, let me show you how to, let me change the camera now. Here we are. All right. This is the, trying to change the camera. Here we go. What happened? Oh, stuck. Excuse me. Excuse me. Hello, can you guys hear me? It seems I've kind of lost the connection. Hello? Hello, guys. Hello. Welcome back. I thought I lost you guys for a minute. There was a problem with the internet connection. Um, Welcome back. Right, so I want to show you how to do a question, how to do the first question on the tutorial sheet, right? So which is question one. Question one is to find the maximum likelihood estimators of VAR and ES, right? Now we know from last week, or was it? We know from last week that the expressions for VAR, for the X has the exponential distribution with parameter lambda, right? The expression for VAR for the exponential is is given by this, right? And the expression for expected shortfall is given by, I mean, we did this as an example a couple of weeks ago, you may recall. All right, is given by this. Right. All right. Now the question is to find the maximum likelihood estimators for var and es. Right. So the only in these two expressions, the only parameter that needs estimation is lambda. Right. P is a fixed number, so you need to estimate lambda. So to estimate lambda, I'm going to use the method of maximum likelihood. So the first thing is you need to write down is the likelihood function. The likelihood function is the product of the density function okay. Now if you simplify this, you will get this, right? Okay, now the next thing to take is the log. So you take the log of the likelihood function, which will be n log lambda minus lambda. Okay, all right, guys. And the next thing to do is the derivative. The derivative with respect to lambda is okay, is this, right? And you set this to 0 and solve for lambda. So if you solve this equation for lambda, you get lambda hat equal to n divided by the sum of xi, right, which is equal to 1 divided by the sample mean, right? Now the second derivative, the second derivative with respect to lambda is this, which is less than 0, right? So hence, excuse me, hence, this is the MLA of London. All right, guys. Okay, now to find the MLE for var, all you need to do is to substitute, excuse me, or to find the MLE for var. Now to answer the question, so hence the MLEs of var and es are as follows. So the MLE for var will be it will be this. Right, and the MLE for ES will be okay. All right, so this completes question 1. Are you okay with this or not? Any questions, guys? Hello, guys. Talk to me. Are you okay or not? Yeah, you don't need to upload your test solution to Blackboard. I know. Some people, maybe some of you have received an email from Blackboard saying that why. Just ignore that email, okay? Just ignore that email. Because the department has been putting a lot of pressure on me to submit to Blackboard, but maybe I will try to send you an email later about this. If they change the policy that everyone should submit to Blackboard, I will try to do that from the next, not this quiz, but maybe the quiz after this, right? I will try to change the policy so that people can in the future try to submit through Blackboard everything. But I know Blackboard is really a pain. I mean, I find it very annoying. I find it very annoying to use Blackboard. I mean, I'm sure you guys also. Right. So, but anyway, somebody has to put up with Blackboard. I don't know. Anyway, okay. All right. So this is question 1. Next question is question 2. The question 2 in question 2. So question 2 here we have a random variable x that has PDF equal to this. All right, this is the PDF, and x lies between 0 and 1. Okay. Now, I think I did this question about a week or 2 ago. And for this question, you should remember, I'm sure you guys have better memory than I do. For this random variable, the expression for var was equal to this, you should remember. And the expression for expected shortfall was equal to this. Okay. All right. Now to find the MLEs for this and this, once again there's only one parameter that you need to estimate, which is A, right? Because P is a fixed number, right? So to estimate A, the first thing is that you need to write down the likelihood function, right? Right? You need to write down the likelihood function. And if you simplify this, guys, you will get this, right? And the next thing is to take the log. Yeah, the log is gonna be log is this, and the next is the derivative. Derivative with respect to A is this, and you set this to 0 and solve for A. So you get A hat equal to this, and then in order to make sure that this is a MLE, you need to find the second derivative with respect to A. So the second derivative with respect to A is right, and this is clearly negative, right? Okay, so hence the conclusion is that follow is the hence all right, hence this is an MLE of A, all right? Okay, guys, so to find in order to find the MLE for var and ES, all you have to do is the following. So hence the final conclusion is that right? Right, and the MLA for expected shortfall. Okay. All right, so this completes question number 2 of the tutorial sheet. Are you okay, guys, with this? Or any questions you have on this, please let me know. Okay. All right, guys, good. All right, so this is question 2. We are done. The next question is question 3. So here you have a normal distribution with parameters mu and sigma squared. And we know from the stuff that we did last week or the week before that, that for this random variable, the expressions for var is the expression for var is this, and the expression for es is this one. I think I showed you this last week or the week before last week. I can't remember now. I'm sure you remember better than I do. Okay. Right now here we have 2 parameters. So we need to estimate mu and we need to estimate sigma, right? Right. So the first thing is the likelihood function. The likelihood function is the product of the density function, which is right. Now you should take the product of this. This is what you get. Right. All right, then you take the log. The log likelihood function is right. This is what it is. Okay. And then you take the partial derivatives. Because you have two parameters, you need to take the partial derivatives, not the ordinary derivatives, right? I'm sure you know that. So the partial, some of you may find this boring. I don't know, you've done this many times before. The partial derivatives with respect to mu and sigma are as follows. So let's first find the partial derivative with respect to mu. All right, this is, you will get, if you do the differentiation, you will get this times the sum of xi minus mu. Yeah, this is what you will get. Now this one you can simplify to sum of, sorry, excuse me, sum of xi minus the sum of mu. Right? Now sum of mu is n times mu. All right. Okay. Now let's set this to 0. All right. And let me call this equation 1. All right. Okay. All right. Next I'm going to go to the partial derivative with respect to sigma. So the partial derivative with respect to sigma is going to be minus n over sigma plus 1 divided by sigma cube yeah, okay. Let's set this to 0, and let me call this equation 2, right? Now from equation 1, which is this one, right, you can see that the estimator for mu is equal to 1 over n times the sum of xi, yeah, and this is of course equal to the sample mean x bar, right? All right. Now from equation 2, which is this one, right? If you solve for sigma, you will get this, right, equal to 1 over n times the sum of xi minus mu squared, right? Okay, all right. Now mu we already have estimated, so I'm going to replace mu by mu hat, right? So mu hat equal to x bar, so this will be 1 over n xi minus x bar squared. All right. So this is the MLE for sigma squared, and this is the MLE for mu. All right. Okay. There is a way to check if these are MLEs by taking the second order derivatives, but it'll take a long time if I try to do that. So I will just assume that these are the MLEs without actually checking. Oh, partial derivative about u is wrong. Is that right? Okay. Let me check this one. The partial derivative with respect to mu is this one. Yeah. Oh, yeah. You're right. You're right. Yeah. Sorry. There shouldn't be a 2 here. There shouldn't be a 2. There's not 2 here. Thank you, sir. Thank you very much. I apologize for this. There's no 2. Thank you very much. All right. Anyway, it doesn't change the answer. Answer is still the same. So the answers are that that this is the MLE for mu and this is the MLE for sigma squared. So hence the conclusion is hence the MLEs of var so this is the MLE for var and the MLE for ES is this. Okay. All right. So mu hat and sigma hat are given by this guy and this guy. All right. So are you guys okay with this question? Are you okay with this, or do you have questions? Hello, guys. Talk to me. Do you have anything you'd like to ask? No questions. Okay. Thank you. Thank you, guys. All right. So let's go to question number 4. Question number 4 is about the log normal. You are told that X has a log normal distribution with parameters mu and sigma squared. And the CDF for the log normal, if you don't know, is given by this. This is the CDF for the log normal distribution. Okay. Right. All right, now to find the var, in this case, I don't think I did this question before, so I will try to find the var first. So set this equal to P, which implies phi sorry, there should be sigmas, not sigma squared. equal to P, right? Now this implies that right, and this implies that log of x yeah, and finally this implies that x equal to exponential right. So this implies that var okay. All right. Now to find the expected shortfall, you will use the formula that is given to you. So you substitute it here. Okay. And you got okay. This is the expression for var, and this is the expression for expected shortfall. Right now, you can do the MLE as in the previous question, but I don't think I will have the time to do it. So I will just write down what the MLEs are. I'm sure you guys are capable of doing this. So the MLEs of mu and sigma are, it's very similar to the previous question I did, right? So if you do it like that, then that you will get mu hat to be equal to this, and you will get sigma hat. You will get sigma hat to be equal to the following: the sum I from 1 to n of log xi minus mu hat, right? Close brackets, squared, and the sum and the square root applies to the whole thing. All right, so these are the two estimators you will get. You should follow the procedure. You should follow the procedure. You don't need, you don't need to solve this integration. I think it will be difficult. Well, it may be possible, but you can try. Yeah, you can try doing it. Yeah, I think it should be possible. It may be possible to solve this integration, but you can try that in your own time and see if you can. Yeah, I think it may be possible. I think it is possible. Yeah, to solve to do this integration. Right. All right. So Are you okay, guys? So in the next page, I will just write down the expressions for the MLEs. So hence, the MLEs of mu and sigma are, yeah. All right. First, the MLE for mu. Sorry, for I'm sorry. What am I saying? Let me text this away. What I wanted to write is this. Hence, the MLEs. Hence, the MLEs of var and ES are right as follows. So the MLE for var right, this is the MLE for var, and the MLE for ES right. Okay, so this is the end of question 4. Are you okay with this or no, guys? Any questions on this? Guys, you okay? Okay, good. All right, the next question is the next one is the question 5. Question 5. Let me see, I'm trying to find out where it is. Oh, it's here. All right, question. So let me take this away. So question 5 is this. So you have the PDF equal to okay, this is the PDF, right? Now, I don't think I did this question before, so let me find the, in order to find the var and ES, first you need to find the CDF, all right? So the corresponding CDF you need to integrate the PDF with respect to y, right? Which is this, yeah. Now this integral is easy. All right, and once you take the limits and simplify things, this is what you will get. Right now, to find the value at risk, you need to set the CDF equal to P and solve for x, right? So that's what I'm doing here. So right, and you should solve this. You should solve this equation for x. This is what you will get. You will get x equal to theta 1 times p to the power 1 over theta 2. Right? So hence the value at risk is equal to theta 1 times p to the power 1 over theta 2. All right. Now to find the expected, I'm running out of time, so I will do it quickly. To find the expected shortfall, we use the formula, the familiar formula. Right? If you use this formula, after substituting and everything, you will get, let me see what I get. You will get something like this. Correct me if I'm wrong, but this is what I'm getting. Yeah, divided by 1 over theta 2 plus 1. All right. So this is what you will get for the expected shortfall, and this is what you get for var. Now there are two parameters, theta 1 and theta 2. You need to estimate them by maximum likelihood. Now the procedure is the same as what I did for question 3, so I'm not going to repeat. I'm not going to repeat that. So if you follow the procedure of question 3, the MLEs MLEs of theta 1 and theta 2 are as follows. So theta 1, you get maximum of x1 to xn. Yeah. And for theta 2, you will get n divided by n log of theta 1 minus the sum of log of xi. Right, so this is what you will get for the MLEs of theta 1 and theta 2. So hence the conclusion, just sorry for running out of time, hence the MLEs of var and es are, yeah, as follows. So the MLE for var is this, right? And the MLE for ES I'm sorry for running out of time. I apologize. All right, so this is the end of question 5. Question 6, I don't have the time to do it now, but you can look up the solutions online. I mean, there are four versions of the solutions for all the 6 questions. You will find them on the course website. Okay. So, and finally, if you haven't completed the UEQ, could you please complete it? I would really, really appreciate it. As you know, I put in a lot of work. I have put in a lot of work trying to teach you like every week. On top of the videos, I've done the videos for the solutions, and I give you like 4 versions of solutions every week. plus the quizzes every week, which are returned on the same day. I hope so. If you, I hope you really appreciate this, and I hope you will complete. If you haven't completed the unit evaluations, could you please complete it as soon as possible? I would really appreciate it. All right. Thanks a lot, guys. So see you soon, and have a good break. Have a good Christmas, and also happy 2021. I will see you there. But I mean, I will be in Manchester throughout the Christmas break, so you can contact me 24/7 by email or Zoom or Skype or phone, or even see me in person. I'm happy to see you wherever you are in Manchester. Okay. All right, guys. So have a good break.